Hi, everybody. Hope you're all doing well and that you're safe and that you're going to be relieved from the fact that we're going to complete Chapter 9 with this video and likely one other video. So we can together kind of see light at the end of the tunnel. Up to this point in Chapter 9, we have been looking at radical expressions. We've multiplied them. We've divided them. We've added and subtracted them. We have evaluated them. We have rationalized denominators. And we have followed some basic rules that we have to adhere to when we are working with radicals. I think there was like a total of 6 or 7 different rules that we literally showed you and that we modeled with. They're important rules that we have to make sure that we honor and follow. Today, in 9.6, the final section, we're going to leave radical expressions and move to solving radical equations. So let's talk definition first. A radical equation is an equation that contains a radical. Example, the radical of t plus 10 is equal to 3. You can see that it's an equation because of the presence of the equal sign, and it's called a radical equation because of the presence of a radical expression that happens to appear on the left-hand side. Now, folks, in order to solve a radical equation, there are 2 key prerequisites that we need to make sure that we honor, that we need to make sure that we follow when we're solving these kinds of equations. Here is prerequisite number 1. We'll not only state it, but we'll prove it. It is a key rule that we're going to have to use when we're solving radical equations. And here's the rule. When you square a radical, you will always get the radicand as your answer. When you square a radical, the radicand will always be the answer. I'm going to show you 2 quick little examples right here that promote that. We're going to take the radical of 4 and we're going to square it. So I'm going to show the little work. The radical of 4 to the 2nd power would mean the radical of 4 times the radical of 4. And when we're multiplying these 2 radicals together, rule number 2 says we multiply the radicals together to get a single radical, which would give us the radical of 16, and the radical of 16 represents the rational number 4. Notice that our answer of 4 matches the radicand of the radical that we squared. When you square a radical, when you square the radical of 4, you get the radicand as your answer. Our answer was 4, and it just so happens that that 4 is the radicand. Second, if we square the radical of 3x, that means the radical of 3x times the radical of 3x, multiply the radicals together to get a single one, the radical of 9x squared, simplify the radical of 9x squared. 9 is a perfect square, its root is 3. X squared is a perfect square, its root is x. We get 3x. 3x just happens to be the radicand. Rule 1. When you square a radical, you get the radicand as your answer. So in a few minutes, when we turn our attention to actually solving radical equations, this is going to be the first one that we're going to do. And the key step that we're going to have to do to get this equation solved for t, we're going to have to get this radicand removed from underneath that radical sign. And the only way that we're going to be able to get it removed and taken from underneath the radical sign, completely underneath it and exposed, we're going to have to square this side. We're going to have to square the other side as well. But for right now, we're going to have to square this. And although I'm not going to put parentheses quite yet, but if I put a parenthesis there, and I put a parenthesis there, and I put an exponent of 2 there, that is going to look like those. And when we end up squaring the radical of t plus 10, we will get t plus 10, period. Because when you square a radical, the radicand is your answer. And so it'll get exposed. It is a precious rule. It is a key rule that we need to make sure that we honor. And then there's a second. The second is called the squaring property of equality. And I'll read it, and then we'll kind of go through a little proof. The squaring property of equality says, when you square both sides of an equation, the solution or solutions, the solution or solutions of the original equation will be found among the solutions of the squared equation. Let me just repeat it for the sake of repeating it. The squaring property of equality says, when you square both sides of an equation, the solution or solutions of the original equation will be found among the solutions of the squared equation. Now we're going to come over here on the opposite side of that statement that I just read. And we're going to show you a proof of this squaring property of equality. I'm going to start out with this original equation. X is equal to 8. Notice what the original equation tells you that x is. It's 8. It's not anything else. It's 8. Put an arrow to it. This is the original equation. Now, folks, you know that to any equation, we can add the same number to both sides of an equation, and it will keep the equation balanced. You can subtract the same commodity from both sides, and it will keep things equivalent. You can multiply to both sides. You can divide to both sides. But something very unique happens when you take both sides of an original equation like x is equal to 8 and you square both sides. Something unusual can happen, and we're going to see it here. Let's take the left-hand side of that original equation x, and we're going to square it. Excuse me. And we're going to do the same thing to the right-hand side. We're going to take that value on the right-hand side and square it as well. And when we do that, we get x squared is equal to 8 times 8, 64. I drew an arrow to this one. This one happens to be called the squared equation. This is the original equation. This is the squared equation. Now notice what happens. Let's solve this squared equation. Notice It's quadratic. X squared is equal to 64. It's a quadratic equation. The only way that we have solved a quadratic equation up to this point is by factoring. So we're going to take this quadratic equation and we're going to solve it by factoring. And in order to solve it by factoring, we're going to have to put the equation in standard form. And that means we're going to have to move the 64 from the right-hand side over to the left. So I went negative 64 on both sides. And we got x squared minus 64 is equal to 0. San Francisco, standard form. And now we're going to take the polynomial that's on the left-hand side and we're going to factor it. GCF? No. 4 terms? No. Trinomial? No. Binomial? Yes. The difference of squares? You bet your boots. Difference of 2 squares. When we factor the difference of 2 squares, we always get 2 binomial factors, and they are always binomial conjugates. So one of our factors is x plus 8. The other one is x minus 8. Follow the arrow up here. We now use the zero factor property to obtain the solutions of the squared equation. X plus 8 is equal to 0, or x minus 8 is equal to 0. Negative 8, negative 8. One potential answer, negative 8. Positive 8 on both. A second potential answer, positive 8. Now you see, if it was an ordinarily quadratic equation that we were solving, there would be those 2 solutions. But what is critical when you are squaring both sides of an equation? You must check your solutions. You must check your solutions because one of the solutions, or maybe more, one or more of the solutions that you obtain from solving the squared equation might have to be discarded. Because you see, these 2 answers that we got from solving this equation, we have to check both of these answers into the original equation. Go back up to the original equation. The original equation says that x is 8. Nothing else. It's 8. We got 2 proposed solutions down here from this squared equation that we got. One of them was negative 8. The other one was positive 8. The positive 8 checks because the original equation says that x must be equal to 8. And it is here. So this one definitely stays. But this one cannot stay. Negative 8 does not check into the original equation. And when you are checking a radical equation, you're always substituting the value or values into the original equation. Not the squared equation, the original one. This is the original one. Negative 8 doesn't check. Negative 8 has to be discarded. Now, that solution of negative 8 that I just discarded, this is a key little vocabulary word. I know it's written small because I was down at the bottom of my board. That x value of negative 8 is called an extraneous solution. Extraneous. An extraneous solution is a solution that is not permitted. It cannot be a solution that is accepted. Extraneous solutions must be discarded. Negative 8 has to be discarded. Only positive 8 will work. Now, if I can have Kristen just kind of go back to the squaring property of equality. Now, I want to read it again. When you square both sides of an equation, the solution or solutions of the original equation, the solution of the original equation is 8. The solution of the original equation will be found among the solutions of the squared equation. Here were the solutions of the squared equation. Notice the solution of the original equation is found among the solutions of the squared. It's right there. But you see, this one right here, he has to be discarded. He's extraneous because he doesn't check into the original. So, I want to come back to this statement right here because it is so important. When you are solving radical equations, you don't have the option to check. You must check. You don't have to do that with other types of equations, but with radical equations, you must check your solutions into the original equation, because you might find one or more than one that has to be discarded, that's no good, that has to be rejected. Now, I'm going to erase this part right here. I'm going to erase some things that I want to. You already had the chance. You know you can pause. You can write this information down as you need to. But I'm going to get rid of this stuff. And we're going to begin by taking a look at just one equation that will finish off this first video. And then the second video, we will handle the rest. Now I'm going to grab this sheet of paper and I'm just going to